You may have heard that the solar system formed over 4.5 billion years ago. But where does that number come from? How can we determine the age of the solar system? It all began when a portion of our parent molecular cloud began to collapse in on itself, carving out the material that eventually formed the solar system. As this parent material coalesced through gravity, it formed a swirling disk of gas and dust, with the center of the disk becoming more and more massive. The combining disk of gas and dust became hotter and denser, eventually becoming large enough to ignite our star, the Sun. As that grand process of star formation was occurring, an environment near the young Sun existed where gas was cool enough to condense the solar system's first solid materials. Because these solids condensed from a very high temperature, they contained lots of refractory elements, such as calcium and aluminum, earning them the not-so-creative nickname Calcium Aluminum-Rich Inclusions, or CAIs. And because solid material is required to date rocks and minerals, it was the formation of these first solids, CAIs, that marked the birth of the solar system. CAIs are dated using various radiometric clocks to be 4.568 billion years old, and as such, this is what we use to define the age of the solar system. After these CAIs formed, many of them were pulled back into the Sun by gravity. However, some CAIs were jettisoned outward by turbulent mixing and radial expansion of the disk. Some of these distal travelers ended up in regions where asteroids and planets were forming a few million years later, and we are lucky enough to study CAIs today as inclusions in certain types of meteorites that never melted. Some CAI-like material has even been found in comets, which are thought to form very far out in the solar system, perhaps even beyond the orbit of Neptune. By studying these earliest formed solids, we have learned an incredible amount, not just about when the solar system was formed, but also about the environmental conditions present around the young Sun, about the composition of the initial material that built the solar system, and how material moved around the protoplanetary disk. CAIs represent a snapshot into the earliest epoch of the solar system's history. They are a treasure trove of information we would struggle to grasp without laboratory study of these interesting objects.